Okay, so hi students. So now there is a new topic which is a simplification using Karnaugh map. So if you look at here, each product term is a group. Is a project is a group. W bar x, y bar, and wi represent the sum of the min term in that group. Okay. Now we have some expressions. Okay. Remember we had a lot of definitions: implicant, literal, min term, maximum. Remember all of these definitions. I will be going to repeat a lot of these terms, so please remember. So can you see here, what is this? It's an implicant. Wi is an implicant, but it's not a min term. Why it's not a min term? Because it does not include z. So please remember all of the definitions. Okay, so now if you look at here, if you want to simplify using Karnaugh map, so if we want to simplify using Karnaugh map, so we want to have some grouping. We want to have some grouping. Okay, now if you look at here, these are some cells. Can you see here? This cell, this cell, this cells. All of them are adjacent or not? This one is adjacent to what? This one is adjacent to this one. So can we group this? So this is a valid group or invalid group? Valid group. Why? It's okay. Now if we have a group, so we can have a group of 2 rectangle or 4 or 8 or 16. So now if we have, can you see here? So if we have a function, so if we have a function of 4 variables, what are the possible groupings? 1, 2, 4, 8 and 16. So these are all the possible groupings. Okay, now if you look at all these groups, all the group, it's a group of what? 4. 1, 2, 3 and 4. Got it? Now if you look at here, if you look at all these groups, 1, 2, 3, 4, this is adjacent to this one is adjacent to this, and this one is adjacent. So now we have a rectangle. We have a rectangle. It's a group of what? 4. It's a group of 4. Got it? Now if you look at here, now if we want to identify some more groups, what is this? Rectangle. A group of what? 4. So now this one is adjacent. So this is also a valid group or invalid group? Valid group. Yes, please. Which one? No, this one is adjacent to this. This one is adjacent to this. This one is adjacent to this. So they are rectangular. So can you see here? So this one is adjacent to this. This one is adjacent to this. This one is. So this is a rectangle. So we are already interested in rectangles. Got it? We will do some more example. This is also a valid group. Can you see here? These are, yes.
In this one, the middle one, can we take the one on this rectangle on the right?
No, we can have only a group of what? 1, 2, 4 and 8. So if we put it here, so then we can have a group of 6, and group of 6 is not allowed. Okay. Okay, now please look at here. Please look at here. Now, what is this? A group of what? A group of 4. We cannot have a group of 6. Okay. What about this red one? Group of 4. So we can have a group of 1, 2, 4, 8 or 16. We have a lot of combinations. These are valid groups. Now please look at here. So now group of 6, allowed or not allowed? Not allowed. Like this shape, allowed or not allowed? Not allowed. This one, not allowed. This one, not allowed. So we can have only rectangles, and we can have rectangle of 2 or 4 or 8 or 16, and single is also possible, single one. Okay, now not allowed. Okay, now please look at here. Now we are combining how many squares? 8 squares. Okay, now we have this Karnaugh map. This Karnaugh map consists of how many minterms? How many minterms? 16. Total possible minterms are 16. How many variables? 4. How many possible combination? 2 is for 4, 16. So 16 minterms, 16 squares. Got it? Okay, now we are discussing about different groups. Now if you look at the red one, it is a group of what? How many squares? 8 squares. Valid group or invalid group? Valid group. So now we have a group of 8. So a group of 8 what? It's a group of 8 main term. Okay, now we are drawing this here. What are the name of variables? YZ and WX. Okay, now 0 0 0 1 1 1 1 0, then 0 0. Got it? Okay, now we have these. Let's assume we have this one. So all of them are 1. Assume that all of them are 1. All of them are 1 1 1 1 1 1 1 1 1. All of them are 1. If all of them are 1, so we have a big group. We have a big group. Okay, now if we go from, can you see here, if we go from this row to this row, what is changing and what is not changing? So W is not changing and X changing. Now if you go from column 1 to column 2 to column 3 and column 4, what is changing? Z is changing, and then Y, both are changing. When both are changing, we ignore this. So what will be the expression of this red thingy? W what? W bar. Why W bar? Can you see here? So now we have W bar. So we go from here to here. So it's 0. It will become W bar. Any question? Should we proceed? Okay. W bar. Now we have another group. Please look at this group. Now we have another group. What is the color? Green. What is the color? Green. Okay. Now X is changing. Yes. From here to here, what is changing? Here X is changing, but from here to here, W is changing. So both W and X are changing. And what about Y? Y does not. What is the value of Y? 1. When the value of Y 1, what will be this expression? Y. Got it? Please, everyone, if this is not clear, please let me know. Clear or not clear? Clear. Now, if you look at the blue one is also a group. A group of how many elements? 8 elements. Okay, now we go from column 1 to column 4. Column 1, column 2, column 3. We go from column 1 to column 4. They are all adjacent. If you like, this is a slender. No, this is a complete group of 8. Okay, now what is okay? Now if you go from this column to this column, so now what is the value of W? Please look at here. Now the blue one. What is the value of W? No. In the first column row, 0. Then 0. Because you know 0, 0, 1, 1. So we do not include it. Whatever is, so now for the blue one, so now I'm saying for the blue one, what is the value of X? 0, 1, 1, 0. Changing? Do not include it. What is the value of Y? What is the value of Y? In the first 0, and then it becomes what? 1. 0 and 1. Should we include it? No. What is the value of Z? So here, what is Z? 0. What is Z here? 0. What is the value of Z? 0. So what does this blue bar indicate? Yes, please. C bar. Got it or not got it? Any question? If there is any question, please let me know. Still, if there is a confusion, let me know. Yes, please. Which one? No. The thing is, if you have a bigger group, you will not make it a smaller group, because then there are a lot of possible combination. In the group of 8, we can have one large group of 8. Then we have 2, 4. Then many combination of 2. So we can say, okay, now let's assume if you have this, we can also have this group, this group, this group, this group. So you know. So when you have a big group, you do not divide it into smaller subgroup. So first you look for the big group. Oh? We look for the largest possible group. That is called as prime implicant. When it's prime implicant, you cannot further divide it, because then there will be a lot of combination. Now let's assume if you look at this red one, so the possible combination is what? M0, M1, M4, M5, then a group of this, then a group of this, in a group of this. So how many? It will be like, you know, some kind of like. Got it? Any question? Why, so the possible group, you came late, but I'm repeating it. The possible group can be 1, 2, 4, 8, or 16. No, it's not possible. We already discussed about the impossible group. You know that group of 6 is not possible. So we did all these examples. Got it? Okay. Now we are combining 4 squares. Assume we combine 4 squares. Assume. Now if this is, can you see the red one? The red one. Okay. Now I'm rubbing this off. The red one. Can you see the red one? For this red one, so now we have how many variables? W what? X, Y, and Z. Now we want to move from here to here, column 2 to column 3. What is the value of W? 0, 1. Include or exclude? Exclude. X, 1, 1. 1. Include. What? Which one? 0, 0. Y, yes. Y. What about Y? So Y is 0, not changing. And what about Z? 1. What is the value of Y? X? X, Y bar. So what term? X, Y bar. Got it? Now help me. This green, if let's assume if this is a group, then Y, W, Y. Can you go from here to here? W is 1. And you go from here to here, Y is 1. Got it? Should we proceed? Okay. Yes. Please, you give me the term. What will be the term? You also try. Yes, please. You also try. Everyone try. Try. You go from. Can you see? We go from row 1 to row 4 and column 1 to column 4. Yes, please. Which one? X bar. Yes, very good. Very good. Very good. Very good. So can you see here? We go from here to here. What is this? X bar. And we go from here to here. Z bar. Got it? Because Z is 0. Okay, now combining 2 squares. What is this? Okay, now W 0, W is 0. Y is what? 1. And X is what? No. So W is 0, X is 1. What about Y? Y is 0 and Z is changing. So it is actually W bar X. X is also 1. X is same. W bar X, Y bar. Got it? Again, help me. Yes, please. The guy sitting in the end. What is this expression? Yes. Please go. If you look at this column, W bar YZ. Very good. So can you see here? Now if you look at here, we are changing from here to here. Then W bar and then YZ. Got it? Again, you can have this expression WY bar Z. Okay, now we have all these things. So can you see here? So please look at here. All these things. When we have 8 squares, how many literals? 8 squares. 8 squares mean, so now I am again repeating here. So okay, now please, this is a very important concept. So if we have 8 squares, now 16 squares, Total of possible 16 squares. So we have 16 minterms. 16 minterms. So we can have a square of 8, a square of what? 4, square of what? 2, a square of only 1, and also a square of 16. So 16 square of 16 means constant 1. Square of 8, 1 literal. Remember? Square of 4, 2 literal. Square of 2, square of 1, just 1 1, 4 literal. But for this, what is it? It's a function of 4 variables. Remember, it's a function of 4 variables. So now there are how many possible combination? 2 to the power 4, which is 16. So now if we have a function, so now we can say, we can generalize the concept. If we have a function of n variables, it is a function of n variables. If it's a function of one variable, so if, okay, now if we have 1 square, how many literals? N literals. Function of 1, what is n here? So if a function of 1, we have how many literals? N literals. If we have 2 squares, n minus 1 literals. If we have a square of 4, n minus 2. If we have a square of 8, n minus 3, and blah blah blah. Got it? And 16, n minus 4. So if n is 4, 4 minus 4, so it's a constant 0, so 0 literals, and it's a constant 1. Got it? Any question? Should we proceed? So now we have a Carnot map, and we Carnot map, so we can, in a Carnot map, we can have a function. Now we can say, we have a Carnot map, we have a function, now again I'm repeating, we have a function of n variables. When we have a function of n variables, we have 2 to the power n possible minterms. When we have 2 to the power n possible minterms, got it? So we have 2 to the power n possible minterms, and then we can have a square of 1, square of 2, square of 4, square of 16, 8, and 16, or 32. Okay, so if you have a function of 32 variables, a function of 32 variables, again, a function of 32 variables, 1 square, how many literals? 5. 2 squares, a square of 2, 4, a square of 3. Yes, we have a function of 5 variables. So if we have 1 square, how many literals? 5. 2 variables, 4. 3 variables, 3, square of 3, 3 literals. Square of 4, 1, 2. Square of 16, square of 32. Got it? So now this is how it works. This is how it works. Okay, now we proceed further. We proceed further. Okay, now combining 4 squares. Now you have already, okay, now 2 literals, we already proved it. And then these are all the things. Okay, now look at this expression. Now we have an expression f. Can you see this f? What is f? Explain it to me. What is f? It's a function of 4 variables. So now we have a function of 4 variables, which is f. Okay, now we have resolved it. Can you see here? A, B bar, C bar, D, A, C bar, D bar. What is this term? Minterm or literal? Minterm. What about this? Literal, not a minterm. No, it's not a literal. It's implicant. It's an implicant. Because what? Why it's an implicant? It's missing B. What is about this? Implicant, but not a minterm. It's a minterm and also implicant. What about this term? Implicant. Please remember all these concepts. Okay, now how many possible squares do we have? 16. Why 16? because we have a function of 4 variables. Okay, now please look at here. Now we look at the cell when A is 1, B is 0, C is 0, and D is 1. A is 1, A is 1, B is 0. Got it? This cell. And then what about C 0 and D 0? C 0, D 0. Now we have 1 here for the first term. Can you see here? When A is 1, B is 0, C is 0, and D 0. Got it? For the first term. Agreed? Any question? Should we proceed? Now we look at the second term. When A is 1, A is 1. Can you see? A is 1. And then B is 1 or 0. What about CD? CD is 0, 0. When CD is 0, 0, which row? First row. So CD is 0, 0, so we are interested in the first row. Got it? Okay, now A is 1. Now we are in the first row. A is 1. A is 1 here. Third and fourth column. And B is 1 or 0. B is 1 or 0. So this is actually, so these two ones belong to A, C bar, D bar. Got it? So both ones. So both ones belong to this term. Yes, we can also cancel the first one. So this one is the first one. So now this is, we can, so this, we can also, yes, cancel it. Yes, we can cancel it. You're right, we can cancel it. So this is like, so now the first term belongs to this main term, and these two ones belong to this implicant. These two terms belong to this implicant. Now we have a square of 2. When we have a square of 2, how many literals are there? 3. Again, we have a square of 2, how many literals? 3. When we have, like for this BC, square of 4. How? BC. Now for third one, BC, look at BC. For BC, what is B? 1. When B is 1, what does it represent? Second and third column. B is 1. Second and third column. So now these two column belongs to. Yeah. And then C is 1. Third and fourth row. Third and fourth row. So how many ones are there? Got it? Okay, now in this example, if you look at the previous example, we had number of ones and we derived an expression. Now in this case, what we have now? The expression, and then we are populating the truth table. Got it or not got it? Okay, now please look at here, and I will also tell you a second way to populate. How to populate, I will also tell you the second way. A bar CD. A bar CD, can you see here? A 0. A 0. So in A 0, so we can say the first and the second. Got it? And CD is 1 1. Third row. So now these two. Okay, now I will tell you the second, another way to solve it. Okay, now if you look at here, please look at here. Now we have a Karnaugh map. Now this is the Karnaugh map. Please look at here. AB. AB is what? A is the MSB or LSB? MSB. And then CD. We have 0 0, then what? 1 1, and then 1 0. What about CD? 0 0. And please remember, okay, now 0 0 0 0. What is this? M0? M0? And then? Okay, now M1 start from here. Why? Because AB is here. If AB have been here, remember, now in the previous example we did AB and CD. Then say 0 1 3 2. Remember? Then it will become M1, then M3, 0 1 3 2. Then we add 4. M6, and then add 8. Remember? And then we add -4. No. So now we add plus 8 and 12, 13. No, 7 plus 4.
No, 15 is correct. 14, just 10.
Okay, 7 8 5 plus 8, 13, 6 plus 8, 14. And then what is this? M8, M9, M11, M10. Got it? 6 plus 4, 10. Okay, please remember in the previous example we say okay, 0, 1, 3, 2. But now we have changed AB. Okay, now look at here. What is the first term? Please look at here. Can you see here? So can we say the first term A, B bar, C bar, D bar? What does it represent? 0, 0, 0. What is this? M8. M8 and M8 is 1. Second term. Okay, now please second term. A, C bar, D bar. 1, 0, 0. But now B is missing. So B can be either 0 or 1. So this is actually 1, 0, 0. So it represents what? M8, 9. M8 is already 1. And then M12. Yes, not 9, 9. M12. Got it? Okay, now look at the other term, BC. Please look at here. BC. So now A is missing, D is missing. What is BC? 1, 1. What are the possible combination? 0, 0, 0, 1, 1, 0, 1, 1. And then 1, 1, 1, 1, 1, 1. Okay, this is what? 6, 7, 14, 15. 6, 7, 4, 6, 7, 14, 15. Got it? Method number 2. So which one is better for you? You can use that. Okay, now the last term. Please last term, help me. A, B, C, D. A bar, C, D. A bar, C, D. 0, 1, 1. So B is what? 0 or what? 1. Again, we can replicate this one. 0, 1, 1. So this is what? 3 and 7. M3 and M7. Where is M3 and M7? If you look at this answer and this answer, same or different? Which method is convenient for you? You can use that. Got it? So now what do we have now? So now if you look at here, so now in this example, can you see here? We have now an expression. We have now an expression, and now we are populating the Karnaugh map. Okay, now it's important now because it is a which expression is this? Sum of product or product of sum? Sum of product. So if it's a sum of product, so we are interested in min terms. When in min terms, so we would put 1 there. For max term, we will put 0. Remember, for max term we will put 0, and for min term we should put 1. So now in this expression, so we will put 1 in all the relevant squares. Okay, now then we derive it. Okay, can you see here? Now there is another method, the same method. Can you see here? A, C bar, D bar. What is missing? B. What is missing? A. And then what is missing? D. And then we populate all then. So I want 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now if you look at here, so now this is the common term. We exclude the common term and then we reduce it. So how many ones? How many min terms? 1, 2, 3, 4, 5, 6, 7. So now these are different methods. These are different methods. So one is the method 1, in which we populated the ones. This was method 2, and now this is method number 3. So you can populate all the min terms, so you know that what are the 1s and 0 and how do we do. So please do all these practice at home. Okay, now it's very important. It's very important. Now we have some definitions. Remember, some definitions. What is a prime implicant and what is an implicant? There are two different definitions. Okay, if you look at any square, if you look at we solved any squares. We solved a square of 8, we solved a square of 4, square of 2, and square of 1. Okay, so we had different squares, and each square will give us an implicant. Each square will give us an implicant. If it's a square of 1, It's also an implicant and it's also a min term. But if you have a square of 2, 4 or 8, it will only give us implicant but not a min term, because it will reduce the number of literals. Okay, now if you look at here, so now we have two definitions. One is an implicant and one is a prime implicant. Now, can you see here? Now, this approach, yes, this is an implicant. The yellow one is an implicant, but yellow one is not a prime implicant. Why it is not a prime implicant? Because it has more literals. If you want to reduce the number of literals, should we make the size bigger or smaller? Bigger. So now if we make the size bigger, so this is called as a prime implicant. Okay, now we have a red prime implicant and we have a blue prime implicant. So now these two ones are shared between this prime implicant and this prime implicant. Got it or not got it? So what is the definition of prime implicant? A prime implicant is a product term. Now if you look at the blue one, how many literals will be there? 2. And yellow one? 3. So 3 literals are good or 2 literals are good? 2. So if we increase the group size, so the number of literals are reduced. So now what is our prime implicant? A prime implicant is a product term obtained by combining the maximum possible number of main terms from adjacent squares in the map. Okay, so which solution is better? This one or this one? This one. Got it? Any question? And you know what is a prime? This is very important. What is prime? What is a prime number? It cannot be further divisible. It cannot be further divisible. Now if you have a group of 8, so okay, now if you have a group of 8, it should not be further divisible. So a group of 8 can be divided into 2 fours. So can you see here? Let's assume if you have a group of 8, assume that we have a group of 8. So there are a lot of possibilities. We can also have this, we can have this, we can also have this. So we don't want to do. So that's the reason we want to have prime implicant. So when we have a group of 8, we should not further divide it into for the subgroups. Got it? That's why it is called as prime implicant. So when we have a larger group, we should not further divide it into smaller groups. Got it or not? That's the reason it's called as prime implicant. And prime implicant is only divisible by 1. It should not be like divisible by 1 in itself. Yes, please. Okay, now if we have a group of 8, okay, so we can have a lot of possible combination. We can have, like, let's assume we have a group of 8. So we can further divide it into a group of 4, then group of 4, then we can also combine this, we can also combine this, and we can have multiple combination of a group of 2. So otherwise it will be an endless thingy. So when we have a group of 8, we should not further divide it into multiple subgroups. That's reason we call this as prime implicant. It should not be further divided. Got it? That's the reason that we call it prime implicant. And in prime implicant, initially when we have some ones, I know, twinkle, twinkle, little star, you're okay. So now initially, whenever we have number of ones, so should we be interested in the larger group or smaller? Larger. That's our objective. So okay, now if you look at here, okay, now it has a min term with 3 literals. Efficient or inefficient? Efficient. That's the reason that the blue one is the prime implicant and the yellow one is just an implicant, but not a prime implicant. Okay, now can you see here? Now it's very important. Now just look at this pattern. We have 3 groups. Can you see the same problem? We have the red one, we have the blue one, and then there's the light sky blue. How many implicants? 3. Here, how many? 2. Which one is better? 2. This is also. So can we see here the red one and the blue one are the essential prime implicant, and this shaded one is redundant. Got it or not got it? Any question? Should we proceed? So what is an essential prime implicant? An essential prime implicant is a prime implicant that includes at least one of the min term that is not covered by any other prime implicant. So now can you see here? So this one is redundant or redundant. So we also need to exclude redundant. Can you see here? Now this has redundant, which has two ones which are covered by what? Red, and it was has what? Two ones which are covered by what? Blue one. That's the reason this card is redundant. So what is an essential prime implicant? An essential prime implicant is a prime implicant. Now we have a prime implicant. We have big groups that includes at least one min term that is not covered by other prime implicant. Now we have these two ones which are covered by what? Blue one. We have these two ones which are covered by what? Red one. So that's the reason that it's a redundant prime implicant. Yes, please. Okay, now if we reduce this expression, how many implicants do we get? The first one. How many implicants? 3. One for the red one, one for the blue one, and one for the shaded one. Okay, now if you look at here, how many implicants? 2. Which one is efficient? With 3 or 4? The second one is efficient. So that the thing is, so this is redundant. So it is an essential prime implicant is a prime implicant. So this blue one and red one is essential, and this shaded one is redundant. Got it? Yeah? Yes, we can also have square like this. We can also have square like this. It's not squares, these are rectangles. These are rectangles. We can also take rectangles. And only squares and rectangle are allowed. You know, you missed the first, you came late, and that's the reason that you are. Can you see here? Rectangle of 2, rectangle of 4. Now if you look at here, rectangle 8 and 8, 4 and 4. Got it? And then we can also combine these 4s. We can also like this. We can also have like this. Got it? Which one? No, this one is done. But these are not allowed. Can you see here? These are not allowed. So the not allowed group are like this. We cannot have a group of 6. It's not allowed. This one is not allowed. This one is not allowed. Okay, now please look at here. Okay, now these are the tasks. I'm now turning off the video, stop recording,